ahead and do an example. This is actually page 81, number 4. So it says find the equation of the line tangent to y equals x cubed minus 3x plus 1 at the point 2, 3. All right, so first of all, we already know what x1 and y1 are. They've already given that to us, so we're real happy about that. And all we need now is to find that slope. The slope of that tangent line is going to be equal to the limit as x approaches a, f of x minus f of a, all over x minus a. Now here in this problem, we know what a is, right? A is the x value. And we also know the function. We're just going to replace the y here with f of x. So let's get these pieces here. F of x. All right, f of x is just going to be this. All right. Then we're going to need f of a. So f of a is going to be what we get when we plug 2 into this function. So let me do that over here on the side. What is f of 2? Well, f of 2 is 2 cubed minus 3 times 2 plus 1, which is 8 minus 6 plus 1, which gives me 1. Okay? Oh, sorry, 1, 3. Duh, this is 2 plus 1, 3. All right, so I kind of know what the pieces are here already, right? This is 3, and then this piece is that. And then down here, that's going to be replaced with a 2. So let me rewrite this. The slope of my tangent line should be the limit as x approaches, oh yeah, this one I forgot to mention, that a is 2, of f of x, which is x cubed minus 3x plus 1, and then minus, that's right here, minus what we just got when we plugged a in, or we plugged 2 into the function. So that's our 3. All over x minus 2. All right, let's just clean that up a little bit on top there. Again, not taking the limit yet. I'm not going to let x go to 2 yet. I should get x cubed minus 3x minus 2 over x minus 2. Now, right now, if you try and let x go to 2, what you're going to get on top is 0, and what you're going to get on bottom is 0. And this is really the bad situation. Well, it's a good situation for calculus students, but it's a bad situation overall. So what we're going to do now is we're going to try to somehow algebraically manipulate this so we can get something to cancel, so we no longer have 0 over 0. So we look at what we can do here. Look at the numerator. It almost looks like a quadratic, right? Because 3 terms, right? We've got minus 3x and minus 2, except that this is not an x squared. So we can't just factor that, you know, like we do a quadratic. So we're going to have to do something else with this. So let me grab this for a second. Well, you know what? I'm going to grab the whole thing. There we go. Grab this whole thing. Take it to the next page with me. Oh, no. Get a new page. All right, so let's take just this numerator for a second. Let's see if you recall or remember from your days in college algebra how you can factor something like x cubed minus 3x minus 2. So in case you have forgotten, we have a way of factoring, and it involves using what's called synthetic division. And if you don't remember how to do this, please look that up and review it. But what basically it turns out to be in this case is you look at 2 numbers. You look at the number in front of your highest power of x. You look at the number of the constant by itself, -2. And you're supposed to create this list of possible numbers from it. And again, I'm not going to show you exactly how to do that. But in this case, we would get 1 and 2. That's basically turns out to be all the factors of 2. So you could have 1 times negative 2. You could have negative 1 times positive 2. These things multiply to give you negative 2, which is here. So please look up synthetic division if you've forgotten this. Now what you do in synthetic division is you do this upside down box, and you put in the coefficients of the polynomial you're trying to factor. So I'm going to put in the 1 that's in front of x cubed. I do not have an x squared, so I have to represent it with a 0. Then I put a negative 3. Then I put a negative 2. Okay, and then at this point, I start using these and trying to do synthetic division until I get a remainder down here of 0. So let me try positive 1 first. Synthetic division, I bring the 1 down, multiply 1 times 1 is 1. Add down, we get 1. 1 times 1 is 1. Add down, we get negative 2. Multiply negative 2, this is negative 4. That is not 0 in the remainder, so that didn't work. So now I try it again, and this time I try another number. So let me try here instead of positive 1, negative 1. 1 comes down, multiply, negative 1, add down, multiply, positive 1, this is negative 2, positive 2, and when you add down, you get 0. So yes, that does work. Now what this tells us is that the original polynomial factors, we're using the 1, like a 1 in front of x squared, minus like a 1 in front of x, and then this minus 2, that this is part of it, and the other part comes from this number, x plus 1. So basically, using synthetic division, I can guarantee you that the original polynomial, that numerator up there, it's going to be hard to see, that right there turns into this, right? So what I can do now is rewrite this. Okay, limit x approaches 2. I have the top is x plus 1 times x squared minus x minus 2, and then over x minus 2. Now at this point, I haven't really done anything that's going to help unless I realize that this is now a quadratic and that can factor even more. So assuming you can factor quadratics quite easily, you'd realize that that factors to be x minus 2 times x plus 1 all over x minus 2. And hopefully you see what happens here. We have a common factor, and those can cancel. So now what we're left with is just limit x approaches 2 of x plus 1 times x plus 1, which is x plus 1 squared. And now finally I'll let x approach 2. If x approaches 2, I get 2 plus 1 is 3. 3 squared is 9. So we get 9. Pretty interesting there, huh? Pretty interesting. Okay, let's now look at this same problem. I want you to see that there is a different way to do this. We could use the other definition of the tangent line to do the exact same problem. So, oh wait, hold on. That's just my slope. Oops, I need to get my equation. I'm just blanking today. Remember, I need my equation and my tangent line. So this is my point slope formula. Okay, we said earlier that the point that was given to us was the point 2, 3. This is my x1, this is my y1. So I have y minus 3 equals the slope, which we just found to be 9, times x minus 2. So that's the equation. I can clean this up a little bit. Y minus 3 equals 9x minus 18. And then just go ahead and add 3 to both sides. And you get 9x minus 15. And that is it. Now, that was the way we did this, okay, required synthetic division, which was a real pain in the butt, right? But that's also because we used this definition here of the slope of the tangent line. We also have the alternative definition. And I want you to see how this problem would work out if you use the alternative definition. So remember our two definitions, limit x approaches a, f of x minus f of a, all over x minus a. That's option 1. The other option, limit h approaches 0, f of x, or a plus h, sorry, minus f of a, all over h. we are going to do this one now, all right, to get that slope. So remember what our function was. The function that was given to us was x cubed minus 3x. I forgot what it was, minus 3x plus 1. And to figure out this, what we're going to need to do is figure out what f of a plus h is. Well, for us in this problem, remember a is 2, so we actually want to know what f of 2 plus h is minus f of 2 all over h. F of 2 plus h, the way to get that is to plug 2 plus h into the function. So replace all your x's with 2 plus h. So cube that minus 3 times 2 plus h, and then in parentheses plus 1. All right, I'm going to cube this. That means I'm going to have to multiply this times itself 3 times. I'm just going to do that. 8 plus 4h plus 2h squared plus h cubed. All right, so I'm doing that based on a little bit of knowledge of polynomial expansions. So don't worry yourself too much about that. I mean, you would have to do it on the side, 2 plus h times 2 plus h times 2 plus h. We could have a whole class on fun stuff on this, how to expand those easily, but I'll skip that for now. Then I have here distribute through, let's see, minus 6 minus 3h, and then plus 1. Let's collect like terms together here. Let me see, I've got h cubed, put this in descending order, plus 2h squared plus, you know what? I got a problem. Hold on. Hold on. I expanded that wrong. Geez, it's just one of those days. Okay, 8 plus 12h plus I forgot the 3 that I have to factor those by. Okay, so this becomes what I just wrote, and then minus 6, and then minus 3h plus 1. All right, that's what that is. And then let me collect my like terms together now. So I have h cubed plus 6h squared. Let's see, how many h's do I have? 12, and then take away 3, so 9h. And then, let's see, 8 minus 6 is 2, plus 1 is 3. So I have 3. All right, so what I know now is this top left corner is going to be all of this. The top right corner is f of 2. We already know f of 2 came out to be 3. We did that in the previous problem. Or you can just plug it in right here. Plug 2 in. So let me take this now. I'm ready to take that and try and see what I get. All right, limit h approaches 0 of the top left, which was h cubed plus 6h squared plus 9h plus 3. Then I subtract from that f of 2, which we know is 3. And then I divide by h. These 3's cancel, which is extremely convenient, because now everything has an h in it in the numerator. So I can factor an h out, be left with h squared plus 6h plus 9, divide that by h, and you see, voila, we get our cancellation. And now you can let h go to 0, because you're not going to have division by 0. So when h goes to 0 now, this will vanish, and the only thing left will be a 9. And so the slope of the tangent line is 9 at that point. And then you go on and proceed to get the rest of the equation. So I think this is a much cleaner way of getting that slope of the tangent line using the second definition. All right, let's do another example. Same exact thing. This is number 6 off page 81. Gives you y equals 2x plus 1 over x plus 2. And we're looking at the point 1, 1. So we already know our x1, y1 again. And so what we need to do is get the slope. We get to choose our definition of the tangent line, the slope of the tangent line. So I'm going to go use this one, limit. Here x approaches a, which is 1, of f of x minus f of a, which is 1, all over x minus a